Yeah, well, let me start to zoom and let you take a look at that. The City College information is really quite interesting. So,
this is disgusting to me.
Well, yes, you could certainly regard it as disgusting as well, but it's interesting to people who are involved at the college. Let me get the, quite a lot of similar news here. Yeah, this protest had a big effect, and I thought there was a later one. There was a protest a couple of days ago against the, yeah, this one, yeah. And so after they tried to double the salary of the administrators while cutting the classes, and it got to be such a serious protest that the Chronicle showed up and wrote an article. So that humiliated the chancellor. So now he's pretending it didn't happen. And there's another article, which maybe I can find in the Chronicle somewhere. Well, I would say so, but you have to understand at a certain level of political corruption, it becomes not clear what his job is. But let's see if there we are. So now he's trying to say, sort of like Donald Trump, that he never did that. So here's the later article. And if I can get through all the junk down to it. Okay. Oh, that's right. I remember this one. This one is the Chronicle has some kind of paywall and garbage, so you can't even see the article unless you reload it and stop it halfway through. This is what I often have to do. Oh, that's what they're mad about. Okay. Okay. Anyway, if you freeze it before it finishes loading, you can actually see the article. So now he's claiming that he hadn't approved the raises, and that has to still be approved, which it contradicts what was in writing before. But of course, it's kind of nice. And here's the budget approving it in August. Here's the document saying, here's the new salaries posted on the payroll website. And there's an official letter from the chancellor too here, which is an interesting, example of administrative double talk. So here's the official letter saying that, it's all his fault that you people misunderstood and he never meant for that to be final or anything and stuff like that. But yeah, but there's a list of the top 100 highest paid people here, which I thought was pretty interesting.
Should we guess that you worked on it?
Well, I wondered if I would be on it, but from the looks of the numbers, I don't think so. And they redacted the teachers. So I can't say for sure.
It's a list of the highest paid employees if you don't have the names.
They have the names. How many classes could have been saved with 100,000? Well, I know about three chancellors back, there was a guy who actually leaked out publicly that each class cost about $6,000. And then everybody screamed and yelled at him and he had to apologize for saying such a terrible thing. I have no idea. But that's what the estimate was a few years ago. So it would be a lot of classes for 100 grand. Anyway, here's the chart of the highest paid teachers, which I would blow up if I could. There we are. And so the chancellor himself is 300 grand.
Are these teachers or employees?
These are all employees, including teachers. You see the teachers, full-time faculty are here, but they've blacked them out. But I don't think this is me. I haven't paid close attention to my paychecks, but I don't think that's me. I don't think I'm anywhere on this chart. This chart only goes down to 130 grand. But anyway, it doesn't. They've removed all the faculty and classified and only focused on the administrators in this chart.
Because it's private information.
No, I don't think any of it's private. As a matter of fact, we're all government employees and everything about us is public. And I've seen my salary posted before and stuff. No, we're government employees and the Sunshine Law means it's all public, but it's not in this particular document. But
I mean, somebody could come to the stock and kill it, what department you're in or building. Right?
Well, sure, but there's just a public directory of all the teachers and all the staff that tells you their office and everything. So I mean, we're not secret people by any means, and our salaries are also public information.
Right,
it's out there. How do we get Elizabeth on that list? Yeah, well, that would be good. Yeah. Well, you got to get more degrees and more experience. That's how it goes. It's all just calculated in steps. Anyway, so I thought it was pretty interesting stuff. And we will see what comes of it all. If it follows previous patterns in government corruption, typically they will just apologize and then wait a month or two and then do it again when you're not looking. That's what I would expect. But however, in a similar vein, I was pleased to see this come out because Bloomberg had this fake story about 6 months ago which was dynamite, where they claimed that China was sticking secret extra chips in Apple devices and Cisco devices. What's that?
I have more details in my paper.
Oh, good, yeah. But anyway, this was a big dynamite article, and it was all fake. Everybody denied it. The Department of Homeland Security, all the companies.
I got the guy, the original think of the whole story as a theory.
Yeah.
Talk to the Uber reporter.
Yeah.
And the guy was surprised that Uber reporter come back and verify everything.
Yeah,
Said, wow.
and when it came out that it was totally fake, they said, well, we'll have an internal investigation, and they just never had it, never reported any results, and never retracted anything. And after that, I've never cited any news article from Bloomberg again. They just totally make up lies and refuse to ever admit it. And so I remember that every time I see their headline and anything. They frequently have exciting stories that nobody else has, and I just leave them alone.
But did you supervise Apple and other clients?
I don't know if Supermicro actually lost any clients. They would have if anybody believed this.
Apple, but it was some other reason was typing.
Yeah. Anyway, so it's very interesting, and now they have an article about this. And now what Bloomberg did is take the guy that wrote that and promote him, put him in charge of things. So even though the guy that wrote that article has now been promoted, he's now something more important at Bloomberg. So even though, so it is very interesting in the spirit of government corruption. This is what tends to happen. The worst rise to the top. And I listened to a political podcast with a Russian political theater. He said, in Russia, we all know this. Only the worst people would rise to the top. They're always horrible tyrants. Well, maybe he's right. I had a different idea, but the evidence is not with me. Anyway, this one was a little interesting. I think it's all political corruption today.
When do the Chinese don't want the democracy anymore?
Well, they want it in Hong Kong.
Hong Kong they do.
Hong Kong is different.
Yeah.
The people in Hong Kong are the people that left China.
Yeah.
Those are people different.
I guess so. Well, here's a few more fun ones. So Uber has made a claim that they don't have to give their drivers benefits because they're not central to the business. And I said, that's a little hard to believe. And here is their argument, which actually makes a little bit of sense. Business is not hiring drivers to drive. It is making a website so they can find each other, like Craigslist. And from their point of view, the drivers are just using the website, and the passengers are just using the website, and they're just the middleman running the website.
And so, of course, we should be the ones to do due diligence on drivers before we get on their cars.
Well, that's an interesting issue, but that is their argument. And now that I hear their argument, it makes a little more sense to me than before. They're not actually employing the drivers to do something. They're like the ISP. They're just in the middle. They're not making the websites. They're not viewing the websites. They're just delivering the product. Like, you could argue that if they like publish, these little magazines that say like, buy something and people advertise and other people buy it, and neither of them are actually employees of the magazine, you could make that argument. That's.
But the problem is Uber hold the money.
Well, they get some money, but on the other hand, so does the Penny Saver, the magazine at the supermarket that has people advertising their leftover junk in their garage and other people buying it. They get some of the money. Craigslist gets some of the money.
Airbnb.
You could argue this. Airbnb too. These people are actually middle. Airbnb doesn't actually own the property. They're just a middleman. You could argue this.
No, but then they touch the money, make sure to pass the money around. It's different.
Well, I'm sure we're going to have big lawsuits and lawyers arguing about it, but I think you're on the right track that how you handle the money will make all the difference. And so they might be able to just restructure the business to handle the money differently to escape the liability of having to employ the drivers. We will see.
Won't there be are they pushing, isn't there going to be a referendum next year?
Well, I don't know.
Put all this stuff on hold for.
Did the state already pass a law that Uber have to be
That's the issue. The state passed a law saying that if you hire part-time workers, you have to treat them as real employees if they're essential to the business. In order to make Uber stop doing this, and Uber claimed they're not liable. They don't fit in the requirements of the law, and if they get a good enough lawyer, they might succeed with that. It's an interesting issue. Anyway, Uber drivers should unionize. Well, yes, that's an issue. They probably should, and so I think a lot of people should, and IT people should. Anyway, so this one is pretty amazing. Fitbit apparently has had an update that broke everything, and they're trying to lie about it. And so they asked readers, and readers are all saying the same thing. Since their Fitbit updated, it won't connect, the battery doesn't last, it's totally useless, and there's no way to make it work at all except to like do a factory reset and put on an old version, kind of like Windows 10. That's how Kirk gets the Windows 10 to work up in the lab. He blocks all the updates, goes back to old versions of everything. So they got a lot of these stories. Evidently, Fitbit is in big trouble. And Wells Fargo is making a cryptocurrency, although most of these bank financed cryptocurrencies I've seen are not actually anything like Bitcoin. They are not distributed, they're not public, they're just kept on a central server. So the difference between this and what they're already doing by just putting your dollar amount in a server is just, I think, a matter of cosmetics. But anyway, they're claiming that they can send money across borders inside their company better by putting it on a blockchain. And as usual, I don't see it. How is this any different than what they already have, a number in their own database that goes across borders?
Oh, it's their proprietary tech, so of course it's great.
So is what they're doing now, proprietary tech, although it's probably just SQL Server or something. It's got some proprietary code in it.
No, but the thing is, they bypass the credit card, and you don't have to pay money.
Well, yeah, but I don't think they have. Yeah, that's true. That's the plan. Everybody thinks they're going to bypass Visa and MasterCard, but I think it's all garbage because Visa and MasterCard charge very little and provide a lot of service. And by the time they provide services, like doing something about all the fraud, they're going to have to charge just as much. The only reason they're not.
Like 3%, right?
Yeah, and that's how much it costs us.
That's not small money.
Oh, I think it is. I think the main reason why you don't have to charge that with Bitcoin is because all transactions are final, and if you don't like it, there's no ability to get any refunds, which is not a small problem. And anyway, but that's where they are. And so here's another one. So Andrew Yang claims he's going to give $1,000 a month to a bunch of people to show his universal basic income works. And before he did this out of his own money, and that's legal, but now he's doing out of campaign contributions. And there's a strong argument that violates campaign finance law, but it does not matter because for the last 2 years, the Commission for Election Finance has been unable to do anything. The commission is supposed to have 6 members, and the Trump administration did not appoint anybody to it, so it's down to 3 members, so they don't have a quorum. They can't. So all the cases are just piling up, waiting for a judgment, which will never happen until they have at least 4 people on the commission. So there is no such thing as election fraud in America, and there hasn't been for 2 years. And there may not be again until we have a different president that actually puts someone on the commission. So this is a little bit more of this banana republic stuff where you just cancel the courts and now everything is legal. Or
he already decided two person already, to get money.
what's that?
He already decided 2 person going to receive the money.
2 person.
Out of the 10.
Oh yeah, he already chose some people. Yeah, and he also got $1 million of donations that night. So as far as a financial investment, it was a positive move. If you want to look at it that way.
And there are like 500,000 people applying.
Yeah, but this is very close to just buying votes. But of course, the Bush tax cuts, I mean, I remember getting a check in the mail. Wasn't that the previous Bush just sent us all a check for $150 as part of his tax cuts? I mean, it's, anyway, amazingly corrupt.
I was the one to work and find them.
Yeah, anyway, it's,
Norway is doing the same thing, right?
that's Norway?
Yeah, they have like the oil, and then the oil money, and they give a check every year.
Yeah, but it's
Oh.
that in Alaska also.
Yeah. Well, that's true. Yeah. Well, anyway, I'll get on to the malware analysis stuff here. So OllyDbg is, of course, your best friend. The same thing as Immunity Debugger. And so this was developed a decade ago. This is the graphical tool used to cheat on Windows games and mess with Windows software of all kinds. And so it was 1.1 was the winning version of OllyDbg. It was very popular. And then they rebranded it as Immunity and sold it, which is essentially the same. In between, there was this horrible thing called OllyDbg 2, which is completely useless and just doesn't even show you what's going on. For example, I was looking for this N2HL and N2HS, which are a simple routine to play with, and they are in the software, but they are not visible in OllyDbg 2.0. I don't even know how you could manage this if you want to. It doesn't even find all the functions in the library anymore. It just skips stuff. So it's completely worthless. The only thing worth using is the old version, OllyDbg 1.1 or Immunity. which has modern versions and is updated more. So now if you want to load an exe, you can load it directly into OllyDbg, and you can load a DLL directly into OllyDbg, or you can have something already running and you can attach to a running process, and this is normal for all debuggers. So you just file open an exe if you like, and it will then open to the entry point, which is typically win main, and then it will break and wait for you to examine it and do whatever you want to do. You can attach to a running process here. It will then break in and pause the program and all threads. All right. So you can reload it with Control F2 or debug reload, which I do all the time because very often I wander around, get lost in the code and want to go back to the start. All right, and we've talked about this before. On the upper left, you got a disassembler that shows you the assembly code. It shows you the addresses, the raw hexadecimal bytes, and then the interpreted assembly code. You got your registers on the right, like EIP and ESP and EBP. And you got a memory dump on the bottom left where you can dump any area of memory you want to look at, which is just like you see it in Wireshark, addresses and a bunch of hex and then ASCII. And on the right, you have the stack, which is counting up 4 bytes at a time and showing the entire 32-bit word. And then if it points to something that it can understand, it tells you what it is. So it's really very handy, and we'll play with it quite a bit in the projects here. So you can modify stuff anywhere. We did it last week. You can modify code in disassembler window. You can modify the registers or stack, and you can modify anything in the memory dump. And we did a few of those things last time. The only big lesson I learned is every time you modify anything, you have to save it right away in that pane. One modification at a time. Otherwise, if you make many modifications, you're likely not to be able to save them all. Yeah?
It would be really nice if it had just like some easy save button. Is there some easy save button? Or is it
No, and I spent like 2 years unable to save it. In fact, in previous versions of this class, I would actually go on OllyDbg, find what I wanted to change, and then open hexedit to modify because I couldn't figure out how to make any modifications stick from OllyDbg. And I finally Googled enough to find people that had solved it. Yeah, you know, these is hacking tools, they're pretty user hostile. They're all this way. You get used to them, but you know, reverse engineering is intrinsically kind of insane, and the tools you're using are all kind of like buggy and troublesome. Yeah, you know, there's not actually a lot of money in this stuff. So anyway, then you can view the memory map, which we've done before. This is really very nice, and this gives, the more I go in this, the further I really like these memory maps. So you've got, here's kernel base, here's shell 32, and so on, user 32, these are DLLs. All those have to be loaded in memory. And then you've got the file, lab0901, one of the ones from the book I'm running. It's got a PE header, and then it's got text section, data, and R data. Remember, everything has to have a text section, or you wouldn't be able to run any code. And you can see where they are here. It tells you what memory they start at and how big they are. Notice that if you don't have address space layout randomization, and in a debugger, you don't, everything always starts at 400,000. Every Windows executable thinks it's loaded at 400,000. And the text section always seems to be at 401,000 in hex. So that is a relative virtual address. That is where its internal addresses point. The whole thing is then moved by an offset to an actual different location in memory. But then, okay, now another thing is rebasing. If you load a library, you can load any number of libraries. And the problem is libraries have a natural base address. It's not always 400,000. It could be a different number in every library. So in the header, it specifies its preferred base address. And it usually loads at that address. EXEs, like I say, are designed to load at 400,000. And they'll be relocated with address space layout randomization. DLLs are more commonly relocated because you might import many DLLs. It's possible that you have 2 DLLs that try to load at exactly the same address. Now, Microsoft writes their DLLs to all load at different addresses to avoid this because it is more efficient if a DLL can load at its natural address. But third-party DLLs might do something stupid like put them all at the same address or collide with a Microsoft address. So you might want to use 2 libraries, and they cannot both load at their preferred address. So there's the first 3 instructions here will work if relocated, because these are relative instructions where you calculate something from a base pointer and add variate, you do a calculation. And here you go to 401,000, and that's a relative virtual address. But here you actually go to some address that came from memory, stored in memory. So you stored an absolute address. I've been talking to Carrie about this and everything. A lot of developers like to put passwords in code, hard-coded passwords. And everybody whines and complains when this comes out. And one of the many reasons why this is terrible is you can't change them. Now you try to change the password and you can't find all the copies of the password in all the code. Not only is it more likely to leak out, but you can't change it. And that's the issue. But you might hard code an address in your code, which is a bad procedure for this reason, of course, because whatever hard coded address you got in there will not be right if it's been relocated. So that's the problem. And so therefore you have a thing called the relocation section of the PE file, which includes all the fixes that have to be made if you load this at a different location in memory. And that's why it's not efficient to do. Now you load it and it has to go patch it with all the patches in the relocation section. And so that's, anyway, I got an example of one here. Here's a device metadata parsers.dil, and here it is, text, data, resource, and the relocation section is there, which contains the information used to do this. Of course, when it works, everything's fine. It just means it takes a little more time to load your memory, load your DIL, but you know, that's called rebasing. And you could remove the relocation section, and now it can't be relocated. Anyway, all right, relocating slows things down, and so it's better to give every DIL its own address. So here's DIL rebasing. DIL A and DIL B both want to load at the same place. Here's DIL A and here's DIL B. So one of them, DIL A, got to load at its preferred address of 1 million or 10 million or whatever this is, I guess 100 million, anyway, whatever that is. And DIL B had to be relocated to a different address. And see, they both do have a relocation section, so they both can relocate, so it'll work, but it'll be a little slower starting your program. Now, IDA Pro is a static analysis tool. It opens code and shows you the assembly code and all the segments, but it does not actually load it into memory and run it the way OllyDbg does. So it doesn't do all these memory corrections. So this means if you look at addresses in IDA Pro, they might be very different than the real addresses in running process or in OllyDbg. And I've noticed they don't agree with the addresses you see in like a hex editor. So you get used to this. There's a conversion. You have to add it off by something. There's a way to actually load things exactly where they belong in IDA Pro, but I just find a pointer and work relative to a pointer. That's how I do it. Look for a string I can find and work from there when I'm trying to edit other things. All right, yeah.
Third-party apps try to load in the same memory?
Well, they might. I mean, the point is Microsoft tries to be organized and make sure every DIL is in a different address, but third-party app designers might choose an address that's used by someone else, and they might just use the same address for all their DILs because they just don't understand it very well or don't care. Especially if you get cheap hardware, the drivers tend to be really sleazy, which is why they cause the blue screen of death and such. So it's so you can see threads and stacks. Here's the threads in a program like Cisco's Packet Tracer or something. You can view them in your debugger. You can view the individual threads and kill them, although it's very rare that you would want to do that unless you're writing the code yourself. The threads are the little pieces of a program that move forward. All right, each thread has its own separate stack, and you can see them stack with thread 2 and thread 3 and thread 4. So a multi-threaded program you could analyze piece by piece here if you wanted to. All right. And so to execute code, you got debug run, which is F9. This will just start running and run as far as it can. You can pause it, which is very strange because you're trying to outrace a computer. Pause it while it's doing something, but I guess it might be all right for something like a video game. And you can run to a selection, run until return, run until user code. You can step into, that will do the next instruction, and if you're on a call, it will move into the called function and stop there. You'll go down into the next instruction, even if you're going down. More commonly, you want to do step over to stay at user land and not bother going inside library code and back. But those are all the options you've got. And the main one that I use is F9 and F7 and F8 sometimes. So you could run and click pause, but that's sloppy. The best way is to set a breakpoint. You search and find some kind of mark like a text string, and then you put a breakpoint and run there. That's what we did last time with that SSH tool, PuTTY. So you can run, after you have breakpoint and look at it, you can run to continue, or you can run to selection. You might select code that is never executed though, and then it will just run forever. This is why very frequently I run and a bad thing happens. Now I do debug, reload, and start again. Executing to return will go until the current function returns, which is fine. And execute till user code would be a good thing if you have wandered into library code and you don't like it. There's an option to go until we get back to the text section, which is where you usually want to be. Unless you're actually trying to debug a Microsoft library or the kernel, you probably want to debug the text section. All right, so F7 is single step, F8 is step over, and all right. You might skip things, of course, with F8. All right, and I've got a few cahoots about that, and they should be open in one of my other windows. There, 126, 8A, I think. Is 8 or 9? It is 9, okay, 9A. All right. Randomize is on. One of the other days we did one of these and it was always A, but I guess that was just random luck. Let's see if I can get some answers saved somewhere. Okay. Yep, yep. Kirk has a fan or something of that sort.
Yeah.
You're blaming Caitlin? I wouldn't. Caitlin's usually the funny faces and stuff.
Yeah, that's what I do.
Oh yeah, well I might, but that's one issue about this. People could totally imitate one another and falsify the names and stuff. That's why one of the many reasons why this is extra credit. It's not very precise. All right, I'll wait a few more seconds. I think 9 might be the number. All right, 2. All right, looks like it. All right, so how do you set a breakpoint? F2, yep. You got a little practice to get used to that. All right. How do you modify a line of assembly? Yeah. That's space bar, that's correct. How do you step over? That's F8. F8 steps over. All right. And how do you run until user code? Holy cow. There's a key press for that. I don't think I would get this one. Well, yes, I guess I can get it by process of elimination. It must be Alt F9. I thought that returned a exception to the program, but we'll get to that later. So this looks like Caitlin. And that one's Ken. All right. So here, let's get back to it. We're only at 6:25. Oh, let me mention something. I will not be in town next week, but class will continue as usual. I have a volunteer who will open the door and turn on Zoom if you want to come here, and I'll tune in remotely from Sri Lanka. That is my plan. God knows what's going to happen. When I tried to do this from China, it didn't work very well because the Great Firewall was a terrible internet connection, but I've been told the internet is good in Sri Lanka. So supposedly, I'll be able to do it. It will be in the middle of the night there or something. So hopefully all my classes will run next week, but I won't be physically here. I'll be connecting by Zoom. We'll see how well it works.
Who's volunteering?
Different student each night. I've got several of them. But anyway, it's but the room will be open if you want to come here, but you can also just tune in remotely from wherever you are, which is of course what most people are doing anyway. So I figured since all the students are doing it, I can do it too. We're going to see how well it works.
So then the lab as usual?
You can if you like, yeah. Yeah, but anyway, so all right, let's take a look at breakpoints. There's lots of breakpoints. We talked about these before in general. Software breakpoints are by far the most common. These are implemented by just changing a byte of code to CC in memory, which is an interrupt 3. And then there's hardware, conditional, and breakpoints on memory. So you can view them here. I see a comment coming in. Sri Lanka. Oh, yeah. Well, I don't know. I haven't been to Sri Lanka. I'll find out. But after this, I'm hoping to get to Singapore for Black Hat and so on. And so,
gum on the sidewalk, right?
gum on the sidewalk?
Is that
Oh,
a
you
place?
can't even buy gum in Singapore.
Yeah,
Can
but you get whipped or something.
Oh, neat. Well, I better not throw gum on the sidewalk. I wasn't planning on it.
No.
But now that you mention it,
They're real strict.
No, they're very serious.
Yeah.
about it.
well, I wouldn't mind that actually. Anyway, so you
It's too sterile.
okay?
I can't agree, but
Okay.
we
Well,
have our own points.
Well, anyway, if they have a security convention, that's all I'll care about. But anyway, so you can view breakpoints and see them, and you'll see them down here. And they're labeled int3 breakpoints because that's what they are, CC interrupt 3. And these red highlighted things are where the code word's going to break. So when it tries to execute that code, it will break. So that's what you normally have, F2. You can also set conditional or hardware breakpoints or memory breakpoints on read, write, or execute. So it saves your breakpoints. If you open the same file again, it will restore your breakpoints. And we talked about these types before, I think. Yeah, well, here they are more. So the string software breakpoints are quite useful for almost any purpose. One of the more common purposes is you have some encoded strings. So you put breakpoints on parts of it that appear to be useful, and you find a place where it has decoded it for you. You might be able to read the assembly well enough to find the decoder, or maybe you'll just put breakpoints in various places until you zero in on it. But eventually it will decode that, and you can just put a breakpoint on it after it's decoded it for you, and then you don't really have to bother understanding exactly how their encoding works. All right, and then you can view it on the stack. That'll reveal strings as they're used. Conditional breakpoints are ones that will break only when some condition is true, like when some register is above a certain value or something. And so what it does actually is it puts in a software breakpoint and breaks every time it hits that code. Then it goes to the debugger. The debugger in Python calculates to see if the condition is true. And if the condition is not true, it presses F9 for you and resumes executing. So it's just the software of the debugger simulating a conditional break, and therefore it slows down the code a lot because you keep jumping from assembly language to Python and back. But still, it's fine. You can set a conditional breakpoint here, and in your textbook they talk about a poison ivy backdoor, where there is some interesting code, but you only want to break there after certain conditions are true. So you put a normal breakpoint at the start of the virtual alloc function, and here's the stack when it appears. So virtual alloc is what allocates a range of memory. We're going to use it later in return-oriented programming exploits in 127. And so here it's going to call virtual alloc, and here's various parameters down there, and you can see how big the size of the area it's allocating is. And a fairly common thing, which some of the malware samples we're going to analyze is they have a data section that contains code. They avoid antivirus by not having it in the expected place. Then when they run, they allocate memory, put it in memory, and run it. I've written this in Python and stuff. This is really easy to do in every language, and it's amazingly effective at fooling antivirus products because they don't think about interpreting the data as code. So you have to allocate a space to put in the code. So how you frequently allocate space, though, so you'll call this function many times that's boring, and you only want to examine it if it's allocating enough space for your code, which is something like 1,000 bytes. So you'd look down here at the size parameter and only want to break when you enter this function if the size parameter is big enough. So that's what you do here. Breakpoint conditional, and say if it's bigger than 100, then break. That will tell you only the allocations of memory that are bigger than 100 bytes. And 100, I think it's probably hexadecimal. So that's the game. Now there's hardware breakpoints, which are what you would use because software breakpoints modify the code in memory. And you might have integrity verification that does something like a hash of the memory and notices that this code is modified. Or otherwise that might not be acceptable. So you have hardware breakpoints in the processor just for this purpose. It has some registers just to make addresses where it will stop, where you do not have to modify any code. But there's only 4 of them at a time, and you can use them. They are not perfect. And you can set memory breakpoints that check if you try to use an address, read, write, execute, or any access, and so on, at any time to use this memory. And so you can only have 1 memory breakpoint at a time, and it implements them by changing the attribute of a block of memory to create an exception when it goes there. So it is kind of unreliable, as you can imagine, and kind of slow, as you can imagine. Simulating that is kind of clumsy. And so anyway, then there's DLLs. executables are what we did last time with something like putty. We understand them, they're pretty simple, but you might want to examine the DLL. Now you can, all right, you can look at the executable code and you can set a breakpoint on access to the DLL, and that will break anytime you go into that section. That's one time you might want to do that. So let's take a look more cahoots. Get rid of this. And it should be 9B, which is here. Okay.
Have fun in Sri Lanka.
Yeah, I should be all right.
Indonesia is having a Wi-Fi.
What's that?
Indonesia is having a Wi-Fi.
Yeah, wildfire. Yeah, no, Sri Lanka is having monsoons apparently. Yeah.
But wildfire, they supposed to cover Singapore.
Oh my,
Oh,
that's pretty harsh. Yeah.
So get ready for your accent.
It'll be smoky in Sri Lanka. Ah,
No, you then you gotta go to Singapore.
but it's no. I'm going to Sri Lanka, and it's pouring rain there. It's going to be hot and rainy, so that should wash away the smoke. I'm hoping. Anyway, we'll see.
But did you say you want to go to Singapore afterwards?
Yeah, but not right away. That'll be probably next year. They have a black hat in Singapore.
There's a lot of fun stuff to do.
It could be, but it's probably all wasted on me. I'm a total nerd. I just care about the security convention. But anyway, I might go do some of it.
They have good food.
Yeah, yeah. Anyway, they got people that want to learn hacking. That's what I care about. So what's the most common breakpoint? All right, those are software breakpoints, good. All right, what kind of breakpoint can have only one?
condition. Call it swag in the military.
Swag?
Swag. Stupid wild ass, yes.
Oh, yeah, yeah. Yeah. All right, the one breakpoint's on memory. You can only have one, and it's simulated with a clumsy process. All right. What kind of breakpoint gives you 4 and no more? That's hardware. Yep, there's just 4 registers. All right. So these look like repeat offenders. I got Caitlin from Lincoln and Caitlin and WITB in twice. And Anton. All right. Well, I guess we can just keep going with this. So, all right, then we can talk about loading DLLs. So you could load a library instead of an executable. Now you can't load it directly. You have to have some executable somewhere. So there is a program called loaddill.exe that will just load the DLL, and you can then press play to load the DLL. When you run a DLL, DLLs always start at DLL main. DLL main is the entry point. And when you load a DLL, it automatically executes the code at DLL main. That is what prepares the DLL for use. A library will have maybe 100 entry points with different names to run different functions, but it runs DLL main when you first load it. And that's why if you're writing malware and you're putting malware in the DLL, which is extremely common because programs can be easily tricked into loading the wrong DLL, and this is the most common way to inject malware into the system, you put your malware in DLL main, because that will run as soon as it loads. You don't need to bother jumping into something to get it going. So in OllyDbg, you can load the DLL directly. I don't think I'll do it live this time, but you can load this thing and it will, you can't export it. You have to reload the DLL and then it will export it, and you can see this window. So you can actually run you can see all the library functions here, like get server by name. There's a whole drop-down list of all the entry points, and you can now fill in the registers and the arguments here. So you can manually call a function of the DIL without having a program call it for you. And since these are library functions, they have parameters and such. So you can load a ntohl. Ntohl is what converts a 32-bit number from network order to host order. Remember this, the network addresses have to have the most significant bit on the left, but it's stored as integers in the system. They have to have the least significant bit. So all this does is reverse the order of 4 bytes. It's about the simplest function you could ask for. So it looks like this. You put that in the argument here, 7F001, and then you can run it and see that it will return the value of the thing going the other way. And you can see it there in EAX. The same answer backwards. This is 7F0001, and that's 010007F. So it's not a very exciting function, but you do get to see what it looks like to load a DIL and run an individual library function in the debugger if you want to. This is pretty esoteric. I've never had to do this. I'm usually what's that?
What's the name of the function?
N2HL. So that is some kind of abbreviation for network order to like hardware storage order or something. It's kind of like the functions that turn integers into text and that sort of thing. Simple conversion function. And remember, I tried to do this in OllyDbg 2, and I couldn't because that library is not visible because OllyDbg 2 is horrible. So I learned what everybody else learned, never use OllyDbg 2. It's just broken. I don't know why they bothered. Anyway, then you can trace things. You can do a backtrace or a call stack trace or a run trace. And I've never used these in Olly, but I have written my own code to do it in GDB on Linux. So a standard backtrace, you can actually use the minus key to go back. But it's not really like the undo in Microsoft Word. All it does is go back to see where the previous instruction is, but it does not reverse the effect on registers and stuff. So you can't really go back and resume execution from another point. You can do a call stack trace, though, and this is important. I often do it at the command line in Linux. This shows the sequence of calls it took to reach your current location. So here's this simple game we had here, the one you have in the project, 000.exe, where your dog figured this out before you. And here's the entire main of this function. We looked at this last time. On the right, you can see more or less the C code. It does a put S, a scan F to read something, and then it either prints you got it or your dog figured it out before you, a simple guessing game. And you can step into puts and then view the stack, and you will now see the stack. So I'm in a kernel routine, then there's a string here, and then I'm in puts. This, remember, as you run a program, you start in the operating system, you move into main, then you call something like print S, then you call something else like a kernel function, and you're many layers down. And this shows all the calls that got you here, like a dream within a dream. So that's what a call stack is. It is where you are, and there's not just one location of where you are. In principle, you could just give me EIP, but it's more accurate to say I was on like the 5th line of main, and now I'm in the 7th line of put S, and now I'm on the 8th line of some kernel function. You're at all those places at once. And when you return, you will resume at all those functions as you return to get back up towards the operating system. So if you step into it again, then you'll be digging down even deeper into some Microsoft library code that eventually is going to print this message on the screen. So when you return, it will pop back up. So you can see how deep you are and how you got into here. And this is common. Of course, the main purpose of these things is not to reverse engineer, it's to debug broken code. And this would help you understand what you called and what you called and what was missing. But it is very useful for reverse engineering for the same reason. All right. All right. So that's the entire main in OllyDbg again. We've seen that before. All right. So you can do a run trace. And here's another call stack of another function where it got really deep. Anyway, so there's also something called a run trace. You can highlight some of the code and turn on run trace, and now it will actually record everything so you can run it backwards like you could in Microsoft Word with the undo button. It can be done, but it's very expensive. It's using up a lot of memory and a lot of time to record all this junk. So you don't do it for the whole program, you do it for some region of code. I've never used it, but it might be useful if you have some really baffling stuff you're trying to figure out. All right, anyway, so this is what you do. You highlight some code, run trace, add selection, and now you can step through it and then back through it. All right. All right, so we've done that. And you can trace into and trace over another esoteric stuff. You can set a condition here in the debugger. This is what we talked about before, where you're going to pause the run trace if certain conditions are met. So, you can do all these exotic things if you want to, but I'm not going to spend much time on them because we're not going to need them for what we're doing in this course, or indeed for 127 either. Then there's exception handling, which is very important. So we already are used to, we've been using exceptions all along. The interrupt 3 causes an exception. It causes the processor to stop doing what it's normally doing and send an interrupt signal, which can be caught by the operating system and used for something else. And in a debugger, that's what causes it to break, stop execution, and let you examine the conditions. So when you're done, you can then use Shift F7 to step into the exception or step over the exception, or Shift F9 to run the exception handler, because the exception will be handled by something. It may be handled by code that the developer put in there because it watches for exceptions, or it may be passed on to the operating system to pop up operating system error messages if it fails. And so often you just ignore exceptions in malware analysis, but you can exploit exceptions. The exception handler in Windows XP was particularly vulnerable because it was always at the same address and randomization didn't move it. So that was pretty good. And you still are structured exception handler exploits, and we'll be doing them in the exploit development class.
Those throughout XP's lifespan.
It'll what?
The XP vulnerability that was.
It made it easier to write malware in XP. That's all, because there was a certain location you could always find. Anyway, so you can patch code. As we mentioned before, you can modify code by just doing binary edit. You can change the contents of any binary section, or you can assemble, to type in assembly language and change the code, just like you could with a hex editor that could just modify the contents of memory. You can fill it with zeros or with nops, and you can save it like you've done before. You have to go to the right section, right click, and save modifications after each change is the best procedure. Otherwise, it's very easy to get confused. If you change 2 different windows and save it, there's no way I've ever found to save both changes at once in OllyDbg, so I save it after every one change. All right, and there is a technique to analyze shellcode, which is kind of fun. You have hex editors, you have hex shellcode that you've created by techniques we've talked about before. You can just write it in assembler, compile it, and then patch it to get rid of the zeros out of it. And then you can select a region of memory and just show a hex dump. And you can clear the NX bit in the debugger. So you can load shellcode directly in a debugger. Now, I must say, I've never bothered doing it this way because it's pretty easy to write C code that will just take the shellcode and put it in a variable and then run it. So that's the easiest way to do it. You can also do it with Python, but you can do it directly in the debugger if you want to. You can just allocate a piece of memory, put binary code in there, and run it. You have direct control of the machine. And this is why several times I've been frustrated by something in a CTF or something in the projects, and I felt like giving up, and I said, there's no excuse for giving up. If you have a debugger, you have complete access to everything that is happening. There is no possible excuse for not figuring out what's wrong. You have total visibility into everything that's going on, and if you just haven't put in the time if you don't figure something out. Anyway, so all right. And there are logs in the debugger that keep track of what you're doing, that shows all the debugger actions to get here if you want to go back and see what happened. There's a thing called watches. You can have an expression and it will just watch all the values of this as you move ahead. That might be useful. I've never needed it yet, but I might need it. You can label things. We'll do a lot more of this in IDA Pro, but you can add labels to it. If you figure out what code does, you can add your own labels to help guide you. And there are plugins. The debugger is like Wireshark. It is or Metasploit. It's a framework, and you can write plugins and add them in. And there's a community of people writing plugins for IDA. And really, the main one we're going to use is Mona coming up later. Mona goes in Immunity, and it's very useful. We use it in the exploit development class a lot. But here's some. You can have something that will dump the debug process to a PE file. That sounds pretty good. That might make it easier to save your code all at once. I haven't tried it. There's something that hides the debugger. Now, we mentioned this before in other classes. There is VMware aware code that notices it's in a virtual machine and changes what it does. It might use a VM escape to break out of the virtual machine, or it might just refuse to do anything malicious while it's in a virtual machine. And so you would want to have a special virtual machine that hides the fact that it is a virtual machine. And there are techniques to do that. And the same thing's true with a debugger. A lot of code will refuse to run correctly in a debugger because debuggers are not a perfect simulation environment, and they can tell it. So there are plugins to conceal the clues that let the malware know it's in a debugger. And there's command line version and bookmarks just to make it easier.
Similar plugins for virtual machines?
No, I don't think virtual machines support plugins, but I think you can get, I know you can get, I think I've seen some sandboxes. There's like the Norman sandbox and stuff, and I think there's a special sandbox that tries to conceal from the malware that it is a virtual machine. Yeah, it's not as simple as a plugin though. That would be nice. All right, and then you can script debugging. You can automate things. So it has an API and it's all written in Python, so you can create custom scripts that do things. And there's a library, some examples in the book of people doing exotic things there. But that's all considerably beyond what we're going to do in this class. But it is there, and writing those plugins is good for you. Is there an interface for PowerShell? Boy, that's a good question. I don't think so. OllyDbg and Immunity, I think, are open source are Linux-oriented things, and they run in Python. However, by the way, they run in Python 2.7, which is supposedly being deprecated next year. So there are other debuggers. Now, some people complain about my malware analysis, my exploit development class, that we should be using Win32debug and Win64debug. And there's also WinDebug. There are more modern bug debuggers than these that are harder to use. And I think they're more up to date. So those, but as far as I know, none of them talk directly to PowerShell. That's a very interesting idea, though, because PowerShell is very important. I would think, in the grand scheme of things, it would be a lot better to make a debugger that doesn't use Python at all, but uses PowerShell to control the code. That would probably be a lot better going forward. And I don't think that exists, but it'd be a very good thing to have.
Why do people like PowerShell?
Oh, because PowerShell is the way to control Windows these days. PowerShell has all the commands you need to do what you need for domain controllers and the Microsoft password hashes and all these exotic Microsoft objects. It's the natural language for Windows, the way C is the natural language for Linux. Logically, it doesn't really make sense to be using Python on Windows. We're doing it, but it never works very well because it's really not intended for that platform. And PowerShell is totally intended to control Windows, and especially if you get into real enterprise environments with Active Directory and Microsoft IIS and their email client, then you really, what is it?
Exchange or
Now, yeah, but you don't be on Exchange, Outlook Web Access. Once you've got all the Microsoft stuff, then you really have to use PowerShell. It's the only language that really has what you need to script all that stuff.
PowerShell is not some of the Unix commands.
Yeah, PowerShell has a few Unix aliases, but they really point to PowerShell commands. And so if you know Unix, you can do a few simple things like ls and think but it's not the same. And if you really get involved in Windows system administration, you have to learn PowerShell. That's really how you.
PowerShell is not used for like the Unix.
No. The Unix commands are in fact just aliases to the closest matching PowerShell command that doesn't really do the same thing. That's why if you really get into system administration in Windows environments, you've got to learn PowerShell. And it really would make a lot more sense to have PowerShell be the scripting language for the debugger, but I don't think anyone's doing it yet. But it would make sense. Yeah, you had a question out there?
Well, you said what I was going to mention.
Okay, good.
It's connected, PowerShell's connected very much so to enterprise level Microsoft's things.
It is.
It's very hard to use other platforms.
Yeah, and the CCDC speaker that came, he said that he doesn't even use any canned malware. He just writes his own PowerShell scripts to exploit Windows systems. And that's the boss way to go. Then antivirus doesn't catch you. And they call this living off the land. It's considered these days a sort of punk amateur move to use malware where you're exploiting a system. If you actually understood Windows or Linux, you would know how to do whatever you're doing with the native code. You don't really need to add any code. You just need to use the commands that are already there. And then it's much harder to catch you.
That's Alex.
What's that?
That's Alex.
Yeah, it was Alex. Yeah, Alex said that, I think.
Was Alex one of your students before?
Oh, no, they weren't my students. We just met them through the competitions.
For CCDC?
Yeah, CCDC and CPTC.
How come he took a picture with your hacking team?
Yeah, because we were competing. We traveled to Rochester and competed in the competition.
How come he saw your team picture?
I don't know. We didn't win or anything, probably just because he was here. We scored like second place in the regional competition or something. We didn't do too bad, but we never won yet. We're still trying though. All right. All right, so we got another one, 9C. All right. And looks like my battery is not charging. Well, I got enough power for a while. Oh, it's not plugged in. Well, that'll do it. A layer 1 problem. Thank you. That's better. Thank you.
Is it plugged in?
Yeah, it's good.
Yeah, I never owned a Mac, so.
Yeah. Tech support. All right. Now wait a few more seconds.
What was the other gentleman that came with Alex the week before that?
Alex,
James?
I don't remember his name right now. They're on my website though. I'm assuming this must be Caitlin. A little esoteric. All right, let's take a look at this stuff. All right, if you hit minus, what happens? That's a backtrace. That shows you the command previous to the one that's currently being executed. Which one lets you see the previous register values? Okay, that's a run trace, which is different than the backtrace. All right. And which one shows all the functions that are waiting for execution to resume? That's the call stack. Good. And what shows you all the modules that were loaded before the current one? Yeah, that's the log. Okay, good. All right. So WITB, and that, I assume that is Caitlin again, and mhino. Okay. Whoops. All right. And so I've got some new projects up. I've been moving this class to the cloud as quickly as possible. And I just got a new one up today. Let's see if I can get to it. All right, let's try a new window. There we are. All right, so here at 126. And if you go to the projects, here's the legacy stuff using that virtual machine. And I've got a bunch of more of them to add up, but I'm losing enthusiasm for them as I move everything to Windows 2016 in the cloud, which is much better because 2008 is at the end of life anyway. And so you make your cloud machine, you can do the static techniques on it and the unpacking. And I made a dynamic analysis one here because I learned how to write this malware, which will be another extra credit project. Within the next couple of days, I'll put it up where you can start writing malware. It's really quite easy. And so I wrote my own malware because the malware samples in the book will not run properly in 2016. So I wrote my own keylogger. So let's take a look at this one. Let me get my VPN going because City College blocks RDP. And let's take a look at some of this. All right, if I can connect.
Unless they block that too.
Nope, they don't, which is nice. And of course, another option is to use danger zone in this room, but anyway, or go through your phone. But once I'm connected, I can now connect to my cloud machine, and I think I left it running. So it'll have the same IP address. If you stop your cloud machine for a day and turn it back on again, it will have a different IP address. I learned that the hard way. So here we are. All right. So I've got, what I did was I made some malware and I loaded it on a server, and you can download it as key9.7zip and then just unzip it with 7-zip. This is what you usually do. You 7-zip it with a password of malware. And so you'll end up with this keylogger here. And you can analyze it in various ways. And so you can download these tools and run them in your cloud machine. In a future semester, I may have a saved Windows cloud machine with all the tools that people can start from, but for this semester, you're going to have to install the tools to use them. So I put them all in the downloads folder, the unzips. And so, for example, if you, the 7-zip, here's key9.7zip, and you take it, or key.7zip, you take it apart, you get key.exe. That's the keylogger. And if I want to look at it, I could use PEID, for example. So, or PEView. So here's PEView. And so if you run that, you can then open key.exe. And you'll see what it's got here. It's got text, RData, data, and relocation. And down here, it's got the import address table, and you can see the libraries. So it uses advanced API to do a few things. And this is, of course, your first step in static analysis to try to figure out what this thing does. You'll see what library functions it uses. So apparently it creates a file, create file W. It has isDebugger present, which is interesting. You might imagine perhaps that it is actually intelligent enough to know whether it's in a debugger. It isn't. This is in fact harmless. I know that because I wrote it, but anyway, it uses some kind of heap allocation. And you go down here, it does something about getting handles, then it calls kernel, and here it does get async key state. And that is a clue that this is a keylogger, which it is. It's actually getting the state of the keys in the kernel, so it's hooking into them somehow. And the old keylogger that we looked at previously used set Windows hook or something, and that procedure only worked on the old operating system, like Windows 2008. It no longer works on this one, which is why I had to write a new one, which uses this more modern API call. But anyway, you can see some of the information in PEView, and you can run this thing in debuggers as well. So let me go back to my instructions here. You can go to bin text. If you look at the strings, you'll see the name of the log file, the file itself, and another suspicious looking file, C Windows VMX32.64, which is a likely indicator of compromise, just like the other one. That's a file that appears to be pretending to be some kind of driver or something and going into a system directory like C Windows. So that's probably it. And if you scroll through the strings, you'll see the usual suspicious strings of a keylogger, stuff like caps lock and right click and up and down. Those are the records it's going to write when you hit those key presses, and you wouldn't see that in anything other than a keylogger. So now you can dynamically analyze it with Process Explorer, Wireshark, and Process Monitor. And it doesn't, in fact, have any network traffic, so you're not going to get anything in Wireshark, but you will be able to see what it's doing in Process Monitor. And this one, after you start Process Monitor and exclude all the other processes, you'll see everything it does. It reads files, it reads registry keys, and you can examine these. You can see what it's doing. So you'll see the running malware runs here. It comes out in two pieces. The keylogger itself runs, and then it launches another process underneath it. And you can see it running Process Monitor. You can see all the things it does, creating registry keys, loading images. Here it is loading all the libraries like kernel 32 and user 32. This is normal. This is not particularly malicious. This is what any running code would do. And then here it is creating that file, C Windows VMX32to64.exe, which is not normal, that it would put file in that location. And here you're going to see it writing the run key. You can see it here. This is the persistence mechanism. It's going to put in the run key, a automatic restarting function, and then you can try out the keylogger and you'll see that it creates a log file, records all your key presses in the same directory you ran it from. And you can restart your machine and it will relaunch. So your machine is permanently owned from this point on. And I forgot to put in the box how to get rid of it, but this does show you how to stop it from relaunching. Of course, all you have to do is delete that C Windows VMX32to64, and you can delete this registry key to get it to stop relaunching, which is the kind of stuff you do to manually clean off malware. So we do get out in that far. Anyway, that's good, clean fun. And there's another one that's new too, which is down here, hacking Minesweeper. This is very much like what you did to hack Putty. Remember, you had Putty, and you went in there. Now, this is from the Flare-On Challenge. Flare-On Challenge is a reverse engineering challenge that comes around every year. And I did it last year, and it was all about Minesweeper. And this is the first couple levels of it, which I thought was great. So once you have a Minesweeper, remember this old game from Windows XP, I went and got a copy of the old XP version, and I modified it and made this thing that runs called MineSam. So this is Minesweeper, and you can play the game just by clicking on squares and telling from these numbers where the mines are, but that's no fun. We're going to cheat. I learned this from Mimikatz. Mimikatz is malware from a guy in New Zealand, and he's a guy with a great sense of humor. And he, for some reason, in his hacking tool, he wrote cheat at Minesweeper. And I saw that there, and I tried it, and I said, that's pretty cool. So if you just load Minesweeper in OllyDbg and run the game, you can find the memory. You just go down here and find the data section of Minesweeper in memory and dump it out. And it's all full of zeros. And if you just scroll down a bit, click a button, click something so you have something on the board. If you just scroll down, you'll see the mine, the memory. So here's, you've got 2, 1, 2, 1, 1. That just shows up here as B is 2, A is 1, 10 is like the border, F is an empty square, and the mines are like 8F. So it's just like you think it would, just a data structure. These mines are just stored in RAM, and you can just see them. So all you have to do is print out the contents of RAM to see where the mines are. So you can cheat at this game, and you might as well use just a Microsoft tool. ProcDump is a Microsoft tool from Mark Rasitovich, again, who wrote all this great stuff. It just takes the process, the running memory of a process, and dumps it out so you can examine it. So you can just put it in a Python script. It will then use ProcDump to dump out the memory of Minesweeper. It will then hunt for the mark. This is the sequence of bytes at the top of the board. It'll find that and then just print out all the lines after it. So if you run that script, it'll just print out this board showing you where the mines are, and now you can totally cheat. So I thought this is pretty awesome. And if you solve the game quickly, you get a word, which is your flag. So you solve it here, fastest or beginning level, it'll pop out a secret word, because I found the resource section. There's a tool that makes it easier, by the way, called Resource Hacker. Resource Hacker is a script kiddie tool you use to change the resource section, where you have things like graphic icons to make programs look different. And you can do that. But anyway, it's easy enough to do. So then you got an intermediate level you can do. Again, you're going to have you have to modify the script to dump out a bigger game board. And then there's an expert level. And I must say, I found the expert level, even cheating, I could never solve the game fast enough. So you're going to have to find the magic word without winning the game, which really shouldn't be that difficult. We've had a lot of techniques to analyze code. You'll have to, I recommend don't even play the game. I could not find any way to cheat in the game fast enough to win. So you have to win without playing the game, which we've talked about before. You got a lot of techniques. So anyway, that should give you something to do for a while. Are there any questions about anything? Well, I think I'm going to stop the share. I'll hang around for a while and help anybody if they want to work here. Oh, there's a chat question coming in. And they should, right, they should script debuggers with JavaScript. Oh man, Caitlin, you're horrible. Not JavaScript. Anyway, all right. So I'm going to stop the share. I'll hang around in here in the lab as long as people want to work. And next week we'll have class. I will be doing it remotely, but you can do it from wherever you want to be. Tune in by Zoom or come here if you want.
So all right. Next week you're out of the country?
All next week. I'm out of the country, but I will Zoom in for my classes.
Okay.
I got another chat. Have a nice trip. Oh, good. Thank you. Okay. Farewell.